Guess who's back? So, I wasn't here for a long time because I was sick. I had a gargantuan fever. Actually, it wasn't that bad. It was like 38.5, bordering on 39. So, a couple of Tylenols and a fistful of ibuprofen later, I feel a bit better. So I decided to continue the stream in which we build our own Lisp live. So what I'll do now is I want to make sure I understand this here. Basically everything we have written up until now. I want to be knowledgeable in it. I want to know what is happening, and I want to be able, if I need to write something similar in the future, do this without any references. And for that, I need to understand the underlying structure, the underlying code. And I'll do this in a jiffy. Just a second. I just want to test whether my stream works. I mean, it should, but... Yeah. Yeah. I'm back. I'm back. So let me just double check it. I'm just gonna... Okay, I tested it. Seems fine. Seems all right. So I said so many times. This is the code. A macro. I'll go line by line from the beginning, and I want to be sure I know what happens here. Okay, include mpc.h. This is a header file for the microprocessor parser, I think. Standard input output, standard library, regular imports for external libraries. A comment saying Windows. Then we have a macro. Is this even called a macro? How is this called? Let me just check. Oh, how is this snippet of code called in C? It's a macro, right? It's a directive. Conditional compilation. It's a directive. Is it a directive or a macro? Conditional compilation using the if def directive. Okay, conditional compilation. If the compiler is compiling this on a Windows operating system, we do something else. We do something here. We include a string.h library. We create a static character buffer. What does static mean? Static means that this variable can only be used inside this file, right? Yeah, it's a scope. If this declaration is at the top level, it's only accessible within the file where it's declared. Function scope, local scope. Okay. Then we have a method of type car pointer, which takes a prompt. What What is this doing? What is this doing? Okay, before I ask my good old friend ChatGPT what all of this means, let me try. I think the best way to learn is to try stuff on your own. So I'm gonna hopefully I'm gonna understand of f puts and f gets. So what are these guys doing? We have a prompt, standard output, standard input. What do these two lines of code do? Yeah, they are there for handling input and output. F puts. So f puts writes a string to an output stream. And it doesn't automatically add a new line at the end of the string. Enter your input prompt. So this would online C compiler. Okay, so I can write my code here, right? Yes. Okay. Walk me through this method. Explain me what some of these commands do, and create an example to go through. Okay, let's see. I think this is the best way to learn. Okay, readLine function prompts the user for input, reads the input from the console, and returns a dynamically allocated copy of the input string with the new line character removed. I have two questions. Why do we remove the new line character? And why is it dynamically allocated? Okay. I think I'm gonna sneeze. Okay. This function takes a single argument prompt, which is a string that will be displayed to the user. The function returns a car, which is a pointer to a dynamically allocated string containing the user's input. This slide displays the prompt. Okay, so this will display the prompt on the console. So what is this doing? It will take the input, store it in the buffer array, and it reads up to 2048 characters. So next thing, we allocate memory on the heap the size of the buffer. Right. So what is this doing? So we read line, enter your name. Okay. And then this is the user input. fputs function displays the prompt. Enter your name. The program waits for the user. The user types Alice and presses enter. The f gets reads the string, storing Alice in the buffer. Then we allocate memory. Then we copy this. And then we have the user input. Okay, so basically it's just a way to... Why is this needed in Windows? So this is basically just a way to grab user's input and create a dynamically allocated copy of it. And the reason why we need it in Windows is, yeah, of course, because Windows likes some certain utilities that exist in other environments. Okay. So we are all right with this. Next thing is the else block, in which we include these guys, which are some headers for edit line. I assume these will be used somewhere down the line, right? Most probably. Okay. Okay. What are these? These are all MPC parser.t. What is MPC parser.t? Tell me. MPC parser.t. Parser combinators are structures that encode how to parse particular languages. They can be combined using intuitive operators to create new parsers of increasing complexity. Using these operators, detailed grammars and languages can be parsed. Okay, we have some case studies. So what does this do? MPC new. Oh, this is how someone would use MPC to create a parser for a basic mathematical expression language. Expression, product, value, and maths. This is how we create a language, basically the same way we created it locally. So this is the result. And we are parsing the input. So assume this is something that is user defined. We are comparing the input against the maths language. Okay. If you were to set input to this, the printed output would look like this. 4 times 2 times 11 plus 2 minus 5. So we have the regex. We have the expression. It starts with the expression because starts with the expression. Okay. I think I'm getting the hang of it finally. So if I'm not mistaken, this command will create a new parser logic object called number. Parser object specifically for parsing what's presumably a number input. Here's a detailed breakdown. So this is a pointer to a parser object type defined by the MPC library, and so this one, why do we have a method and a string beside it? Creates a new parser object, takes a single. It's a string that names the parser. Okay. Okay. Here's the read line. Add history input. So here I created, so here I'm parsing it. I have the started input, I have it this input. This is the parser object. And this is the result of the parsing. And here I'm evaluating it. Otherwise you have an error, be free. Okay, we have the evaluate method, it's here. Okay, let's create an example. So let's say I have this. And this as well. And here are the contents of the evil method. Let's create a walkthrough for a simple input such as, I don't know, plus 5 times 2, 5, maybe like this. Will this work? Okay. So this is the grammar. This is something that is custom made by us. The input's parsed by this parse method, where Lisp is the top level parser. This defined to recognize the structure of a Lisp-like expression. The results stored in R, which contains the parsed abstract search tree for the input to this. The AST might look like this. then called with the root of the IST, evaluating the root expression. The root of the IST is a Lisp node with an operator plus. This is the root. Okay, the eval function checks if the current node is a number node, which it isn't. And then the operator is extracted, and it results in operator plus. The first operand is evaluated recursively. The first operand is a number, so this is guy, and it converts it to an integer, and it returns 5. Now the second sub-expression is this one. So we extract the operator, and the first operand is evaluated recursively, the second one as well, and then we call the evaluate operator function. And finally, we also evaluate this as well, and we return the result. Okay, simple enough. Simple enough. In this chapter, we had code that evaluates the structure. The internal structure is what we saw printed out by the program. So I'm back to the book. I think I understood the gist of it. I'm still not 100% sure regarding many of these things, but I'm getting there. Okay, I don't care about this. Recursion. Okay, evaluation. Okay. All of this. Okay, let's start with the bonus marks. Write a recursive function to compute the number of leaves of a tree. Okay. Write a recursive function to compute the number of leaves in a tree. So first of all, what are leaves? Leaves are most probably. What are leaves in an abstract search tree? Are the nodes at the bottom of the tree that have no children, and these nodes represent the most basic or terminal elements in the structure of the abstract search tree. Leaf nodes do not have any child nodes. They are the endpoints in the tree structure. So they most probably are either these two, right? The nodes number 5, number 2, and number 5 are leaf nodes. But the operators plus and multiply are not leaves because they have children nodes representing their operands. They have children nodes representing their operands. How? Why are number 5 and number 2 leaf nodes but not operators? comes for the structure and purpose of an abstract syntax tree. They don't have any child nodes. In an abstract search tree, leaf nodes typically correspond to terminal symbols. They are the basic building blocks that do not require further parsing or decomposition. Ah. They're not terminal elements. They are internal nodes that have child nodes representing they are not terminal elements. They are internal nodes that have child nodes representing their operands. The role of an operator in an abstract search tree is to combine or operate on one or more operands. Why is this like this? But this doesn't make sense. I think that the operator as well should be a leaf node. So just to confirm, if we take this definition of a language, only the number is a leaf node. The operator rule is defined as a choice between these four symbols. A node corresponding to this operator will not be a leaf node because okay. Okay, I misrepresented the definition of the language with the way the abstract search tree is constructed. Yeah, the abstract search tree has only numbers as leaf nodes. But I, in my confusion, was beating my head around why is this, these are also symbols, why, and they are unique, they are only one symbols, why they are not considered leaf nodes. But yeah, now I get it. I think this is the best way to prove it. Yeah. Write a recursive function to compute the number of leaves in a tree. Okay. Oops. Long. Maybe I don't mean long. Okay, long. Num of leaves is calculate leaves from the result How to skip lines when going up or down in Vim. How to skip multiple lines. Move down, move up. So okay. So what will we have here? We'll have what's the name of the stupid method? It's called calculate leaves. Okay, calculate leaves. I'm taking an abstract search tree as an input. Okay. But how can I do this? So let me just think about it. Let me just think about it. So what do I have? I have maybe like I have something like this. In the above. How do I know that I reached a leaf node? So basically, it seems that I will just check against the tag, and that's it. So there's no way to programmatically get this information back. I need to. Seems that I need to just compare against the number tag. Or also this. Okay. Okay, this is actually pretty good. Okay, let's do this. 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 If t children num is equal to 0, right? Sum of nodes is 0. So if it's can do this sum of nodes plus plus, what I will do, I will probably return sum of nodes, right? Okay, so I have the base case. I have the return. I just now need to create the most complex part of a recursive function, that is the recursive logic. So so I came here. This one has children. So if it has children, you move through each child and you call this method again. Like here. But why? String, substring. Okay. Check the node tag. Okay. How would I go around looping through every child of uh, of an IST and recursively calling a function. Let's say I want to compute the number of leaves of a tree using a recursive function. How should I do this? Let me just see. Define the recursive function. This function will take the root of the AST. Okay, I did this. Loop through the children. Okay. Base case. If the node has no children, it's a leaf. Ah! Sum of nodes. So actually this will also be... Yeah, I'm an idiot. So this will be 1. And this will be... No! Wait. If the node has no children, it's a leaf. Okay. How am I... Vim, how to remove a whole line? It's DD. Okay. It's DD, and here return sum of nodes, right? And okay, the recursive case. Traversal children. How? I mean, of course, it was so simple. So, return 1. This guy, how do I move? How to move lines in Vim? dd, okay, dd, and then here, paste, move to the end. So sum of nodes for, wait, I don't need this guy. I don't need this guy for int is equal to 0 is less than the children num e increases. I think that's it, right? I think that's it. Leaf count, it's not leaf count, it's not leaf count, it's sum of nodes, right? Sum of nodes. Um, how to copy a line in Vim? Ah, nice. I was like, the last 10 minutes, I was on the brink of sneezing and I finally did this. I wanted to shut down the mic, but what the fuck? Return type defaults to int. Ah, yeah. The return type defaults to int because this is an int. Int. I'm also gonna create an int here. Int. Okay, now finally work. Oh my fucking god. Fucking god. Fuck. Fuck. So what do I have? Plus 5 times 2 and 5. It should be 3, right? It's 9. How the fuck is it 9? How the hell is it 9? How the hell is it 9? Uh-huh. How the hell is this 9? Yeah, it should be 3, but it's not 3. Plus 5 times 2, 5. It should be 3. Where am I? What am I doing differently? Plus 5 times 2 and 5. It's 9. It's still 9. Why? First of all, let me... Okay, let's have... I need to... Two things. I need to definitely install a new terminal here. Does this one have multi windows or something like this? No, it doesn't. Okay, so I'll definitely do this. Vim parser, and here children. How do I debug this? I forgot. How to debug? I always forget how to debug. How to debug in C? Debugging in C. Blah 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 blah. Okay. GTP parser break. What's the name of my method? Break. Calculate leaves. Run. No. Plus 5 times 2, 5. Okay. Print the children none. It's 5. How is it 5? Print the tag is this one. It's 5. How is it 5? Print the children 0 tag. So we have an expression and we have a regex and 5. Yeah, 5 is not existing. So if I go to 0 and I print out contents, if I print out contents, it's an empty string. For 1 it's plus, for 2 is 5, for 3 it's an empty string, for 4 it's this, 5, yeah, I can't access it. Next. Calculate leaves, sum of nodes. Okay. Oops. So if the node oh my fucking god. Sum of nodes, leaf count. So for anyone joining, what I'm doing here is I'm doing the bonus marks from the book. We are writing our own, sorry, we are writing our own natural grammar, and we are doing some additional marks from the book, basically saying write a recursive function to compute the number of leaves in a tree. Okay, this bad. This. But for some reason, I wrote the method. For some reason, I keep getting 9 as a result. Why am I getting 9? Why am I getting 9? Why am I getting 9 is the question. So the question is, why am I getting 9 here? For some reason, I keep getting 9, even though I shouldn't be. I should. Plus 2, 5. It's 5. Why is it 5? Plus 3, 3. Plus 1, 2. Hmm. I create the same method as above in the snippet. But the problem is that for the above mentioned example, I keep getting 9. On the other hand, for examples such as or, I keep getting 5. Another, yeah. String, substring. Oh no, it's here. It's 2 plus 4 times 3. 3. But I don't like the solution at all. Because what if in the future we update our language grammar with new rules in which, I don't know, we can have additional nodes that can be leaf nodes, and they are not only of type of the tag number. I mean, it's good enough for this, but I'm not very. Yeah, but it's. But why do I get 9? Is the question. Eight, 9. 1, 2, 3, 4. 1, 2, 3, 4. No idea. No idea why I kept getting 9. Okay, the second question is write a recursive function to compute the number of branches of a tree. I mean, it's also I don't think it's a lot different than the question regarding number of leaves. So I think I'm just gonna ignore this one. Okay. Write a recursive function to compute the most number of children spanning from one branch of a tree. Write a recursive function to compute the most number of children spanning from one branch of a tree. How could I write this? So if we have plus 5 multiply 2 5, so the most number of children spanning from one branch of a tree, I would start here. I would create a counter, most probably 1. And I'll call it, I don't know, most children. I will go here. It will be 1. Children spanning from one branch of a tree. But how does this even work? The only way this could work is to compute the most number of children spanning from one branch of a tree. This is the tree. One branch is this. this, and this. Okay. How would I write a recursive function to compute the number of children spanning from one branch of a tree? Find the branch of a tree that has the maximum number of nodes. Yeah. I came with the same basic idea. For each node, recursively compute the depth of each of its children and return the maximum depth found. Base case. If a node has no children, the depth is 1. A node with children, calculate the maximum depth of all of its children and add 1. So what is this? Would be 3, right? Yeah. Okay, let's maybe create this one. But let's do this in a jiffy. I'm taking a quick break, and I'll continue today. We will finish. By the way, we will finish, if not all of these bonus marks, at least some of them, and then we'll move on to error handling. So thank you very much for following this. It seemed like my mic was broken. Thank you so much for following these YouTube series on building your own Lisp, and I hope to see you in the next one.